in the domain of science and grandio, secrets the subject of what existed. Before the enormous detonation has mixed discussions and charmed personalities. For a long time, this significant inquiry doesn't merely challenge our understanding of the universe, it challenges the very limits of human knowledge. Imagine standing at the edge of existence, gazing into the vast darkness and wondering what lay there. Before our universe was born, the moment of the Big Bang marked the dawn of matter, space, and all that we know yet. Was there a moment before this? Could there have been a state of nothingness, a silence before the cosmic ensemble began? And if this were true, what was it? Or perhaps there was something far more unnerving that existed before time itself. As we delve deeper into this question, science takes us on a journey beyond the universe's origin into ideas that defy our understanding. Physicist Brian Cox, known for his exploration of the universe's wonders, suggests that something startling could have existed for the Big Bang. He challenges us to rethink our concept of reality and existence. In this exploration, we'll dive into the science, the theories, and the astonishing mysteries that might explain what existed before everything. We'll examine ideas like cosmic inflation, quantum fluctuations, dark energy, and even multiverses. The answers we've uncovered may shock you, but they could also offer new insights into our place in the universe. Prepare to dive deep into a world beyond imagination, where science meets the unknown, leaving researchers in awe and at times unsettled. Let's explore what existed before the Big Bang and why these theories challenge everything we thought we knew. To understand what could have existed before the Big Bang, we first need to carefully examine what the Big Bang truly was. A Big Bang, as scientists define it, refers to the moment when the universe became extraordinarily hot and dense, expanding rapidly to trigger the creation of all matter, energy, and cosmic forces. When we gaze at the night sky, we see evidence of this hot beginning, with galaxies spreading out in all directions from a central point. But why did this happen, and was there a time before this dense, hot beginning? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty or peaceful. Cosmic inflation suggests that before the Big Bang, the universe was in a state that was cold, empty, and stretched out almost like a vast vacuum. However, this vacuum wasn't completely empty. It contained a massive amount of energy that powered the rapid expansion of space itself. This expansion, called inflation, occurred so quickly that it essentially laid the groundwork for everything that followed. In a fraction of a second, space expanded at unimaginable speeds until the expansion slowed and the energy transformed into matter particles and the four forces we recognize as the Big Bang. But what was the nature of this energy? Why did it suddenly explode the universe into existence, and why did it stop? Scientists believe that this cosmic inflation created patches of the universe, each experiencing its own Big Bang. Imagine a fabric stretching endlessly with small bubbles forming here and there. Each bubble represents a universe, including our own. This concept, called the inflationary multiverse, implies that there are potentially infinite Big Bangs and an endless number of universes. Ours is just one of many. This vast mind-bending reality challenges our understanding of the universe itself and leaves us with the question, what else is out there? The idea of nothingness before the Big Bang is theoretical, not real, at least according to our current understanding. Even if you removed all energy, particles, and radiation from the universe, it would still not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that create a tapestry of something. Even in its emptiest form, even if we imagine stripping away all these forces, leaving a dark void the universe, would still create new forms of energy. This fact alone is baffling to scientists as it suggests that true nothingness might be impossible within our cosmic understanding. As we probe further, we discover that space itself has properties, rules, and constants that do not allow it to be completely void. Imagine creating a region with absolutely nothing in it, no particles, no radiation, no energy, yet quantum fields and fundamental constants would still exist, meaning that this nothingness has properties. For example, there's a phenomenon called zero-point energy, which represents the lowest possible energy state of quantum fields. In this state, particles can still momentarily appear and vanish, creating a ghostly echo of activity even in what should be empty space. This challenges our concept of a true void and suggests that even before the Big Bang there was something that scientists are just beginning to comprehend. One of the most surprising theories in modern cosmology is the idea of eternal inflation. If inflation could create our universe, it's possible it could continue indefinitely. Brian Cox describes a frighteningly vast, inflationary multiverse where universes are continually created and keep expanding. Imagine each Big Bang as a spark lighting a new universe, while inflation persists in other regions, creating countless other universes. This process could in theory go on forever. This idea of infinite universes gives rise to an intriguing concept of a fractal universe, where each new universe has the potential to create its own Big Bang. Each universe exists as a separate, self-contained realm unaffected by the others due to the rapid expansion of space. For scientists, this theory is both exciting and unsettling, as it suggests an endless multiverse with no ultimate beginning or end. What if our universe is just one speck in a vast cosmic structure expanding and creating forever? And what if the unsettling truth is that there is no before or after, but simply an eternal cycle of universes forming and decaying? Our understanding of nothingness changes when we consider quantum field theory. According to this theory, the universe isn't a collection of matter floating in space, rather it's a network of energy fields that fill the universe, interacting to create everything we observe. These fields are like invisible oceans, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and vanish in these fields, borrowing energy temporarily before returning it. This phenomenon gives rise to virtual particles, entities that momentarily exist and then disappear, leaving behind a faint memory of their presence. The idea of virtual particles challenges the notion of a true void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you have complete nothingness? According to quantum field theory, you wouldn't. Even in a vacuum, fields remain active sporadically, producing fleeting particles. This constant activity in what should be nothing suggests that the universe doesn't understand our concept of emptiness. The fields and forces persist, filling the universe with a fundamental energy that prevents absolute nothingness. This insight raises a fascinating question. If fields create particles and particles create matter, could the universe itself have emerged from this nothingness as opposed to straight? Assuming this hypothesis is right, it could imply that what existed before the huge explosion was essentially one more variant of the universe, one that imploded exclusively to bring forth our ebb and flow universe. For researchers, this hypothesis offers an elegant answer to the subject of an ultimate start by recommending that there isn't one, rather the universe has consistently existed in some form, transcending our thoughts of time and existence. Early stage gravitational waves are another fascinating concept that could hold clues to what existed before the enormous detonation gravitational waves are ripples in space-time caused by massive cosmic events, and researchers believe that early-stage waves, if detected, could reveal details of the universe's earliest moments. These waves would be remnants from the inflationary period, carrying information about what occurred during the first fraction of a second after the enormous detonation. But what if there were waves that predate even the huge explosion? Some theories suggest that gravitational waves could exist from a pre-enormous detonation time. If such a period existed, detecting these waves could provide direct evidence of events or conditions that occurred before inflation in the hot, huge explosion. However, tracking down early-stage waves from before the enormous detonation is a tremendous challenge. Scientists are developing sensitive instruments to detect these sub-met waves, hoping they will one day uncover a hidden layer of cosmic history. Such a discovery wouldn't just provide answers about our universe's outset, but also about the deeper cosmic forces that could have ignited its presence. Quantum foam, a concept proposed by physicist John Wheeler, is another theory that hints at the possibility of pre-enormous detonation existence. According to quantum mechanics, space isn't truly empty, but is filled with constant fluctuations of energy at the smallest scales. This quantum foam suggests that at the tiniest sizes of existence, particles can appear and vanish in brief moments, giving rise to temporary pockets of energy. This idea supports the vacuum origin theory, which posits that the universe may have arisen from a massive quantum fluctuation in the sea of quantum foam. The vacuum origin hypothesis suggests that what we see as the huge explosion was actually one of these energy fluctuations growing until it became the universe. This view reimagines the concept of nothingness, suggesting that even in the absence of matter, energy, and conventional space-time, there still exists a dynamic reality. If our universe is indeed the result of a fluctuation in quantum foam, then there might be other universes appearing and vanishing within this quantum sea. This idea expands the multiverse hypothesis and suggests that our universe's existence may be far more commonplace in the grand scheme of cosmic phenomena. Quantum tunneling is a phenomenon in quantum mechanics where particles can pass through energy barriers even when they don't seemingly have enough energy to do so. This concept of tunneling is fascinating when applied to the universe itself. Some cosmologists suggest that our universe may have tunneled into existence from another dimension or reality. Quantum tunneling would allow energy to breach an otherwise insurmountable barrier, resulting in a universe emerging from another plane of existence. This hypothesis adds a mysterious layer to what existed before the enormous detonation, as it suggests that our universe may have spilled or tunneled into being from a parallel realm. If this hypothesis holds any truth, our universe could be just one of many that form, evolve, and disappear within a much larger hidden structure. Quantum tunneling proposes that the enormous detonation might not be the beginning, but rather the result of a barrier being crossed, a moment when our universe emerged and merged into the vast unknown. As we explore these theories, it becomes clear that our understanding of the universe's origins is limited, but evolving. The huge explosion was once considered the ultimate beginning, the solitary point from which all existence sprang. But now, with ideas like inflation, the multiverse, and quantum fields, we see a much more intricate tapestry. Scientists like Brian Cox push us to imagine that something existed before our universe, something powerful enough to ignite the enormous detonation and set off the chain of events leading to our reality. The implications of these theories are both exciting and humbling. reminding us that the universe is full of mysteries yet to be solved. So what existed before the enormous detonation? While science may one day uncover more answers, for now we stand at the edge of what we know, looking into the unknown with curiosity, awe, and a touch of fear. The vastness of the universe, its intricate designs, and the secrets it holds remind us that our place in the cosmos is both unique and fleeting. Embracing this mystery is part of what makes us human and inspires us to keep exploring. What do you think lies beyond the limits of our knowledge? As we continue to explore the possibilities of what existed before the enormous detonation, it's important to consider the role of consciousness and the observer in shaping our understanding of the universe. Some physicists have suggested that the universe, or at least its fundamental properties, could be influenced by the presence of conscious observers. This idea is rooted in the famous observer effect seen in quantum mechanics, where the active measurement can alter the state of a particle. Could the universe's origins and its continuing evolution be tied to some form of consciousness, either human or otherwise? This thought challenges traditional materialist views and opens a door to new, more philosophical interpretations of cosmic events. Another area of interest lies in the relationship between time and reality itself. Is time a linear progression, or is it something more flexible, capable of bending and folding in ways we can't yet comprehend? The discovery of time loops or closed-like curves in the fabric of space-time could offer insight into a universe without a definite beginning or end. If time is cyclical or nonlinear, it might suggest that the universe's origin, or the very concept of a beginning, is an illusion. This would imply a much deeper, more complex structure to reality, one that transcends our current understanding of time, space, and existence. Ultimately, the question of what came before the enormous detonation may not have a simple answer. It may push the boundaries of science and philosophy, forcing us to rethink the very nature of the universe and our place within it.